Bom, prezados colegas, convidados da NetBR, gostaria de agradecer a participação de todos nesse nosso último seminário. Em especial, agradecimento ao nosso parceiro, a Conjur. Hoje, o foco da apresentação hoje é um modelo novo de segurança baseado em containers e microserviços, que é basicamente o modelo de infraestrutura moderna. O objetivo desse seminário é apresentar esses novos modelos, como que a tecnologia vem ajudando dentro dessa etapa de transformação digital, garantir que os dados, os serviços, os servidores, as aplicações, e no contexto maior de container, são seguros e confiáveis. Hoje, contaremos com a apresentação do Josh. O Josh, ele é vice-presidente da Conjur, na parte de definição de produtos. A NetBR vem trabalhando com a Conjur já há alguns anos e a ideia é compartilhar com vocês esses conhecimentos. Então, agradeço a todos. Josh, please, you can move ahead. Thank you for everybody. Bye.
Andre, thanks very much to all of our friends at NetBR for the opportunity to speak to you today about Conjur. My Portuguese isn't that good, but I think Andre introduced me. But my name is Josh Bregman. I'm the Vice President of Technical Sales here at Conjur. Today, during this webinar, we're going to talk a little bit about some trends as companies move towards a more digital business. We're going to talk about some of the access management and security challenges of making that transformation. Then we're going to talk a little bit about Conjur, the technology overview, the product. At that point, Dustin Burns, who I have here with me, is going to give you a demo of the product. And then we'll close with a couple of takeaways and key principles for securing the digital business. So this is me. Like I said, my name is Josh Bregman. Conjur is based in Waltham, Massachusetts, here in the United States. I've been working in the area of identity access management and security for over 20 years. This is I think the latest incarnation of the convergence between applications and security. I was an early engineer at Netegrity, SiteMinder. I worked at Oracle and the Oracle ecosystem for 10 years, including part of the Oracle A team that works with Oracle's largest customers. I worked on the Oracle API Gateway. So I've been working in this convergence of security and applications for a long time, and now automated infrastructure and DevOps and how that supports the digital business seems to be the next phase of this problem. I'm now going to let Dustin Byrne introduce. You want to introduce yourself, Dustin?
Hi, everyone. My name is Dustin Byrne. I've been working with Conjur for about a year now, working with customers and prospects to come up with solutions and sort of guide them through this, getting into this new age of modern infrastructure, Docker containers, things of that nature, things that are particularly new to these companies, especially as they get into DevOps. My background is particularly as a software engineer, so I've worked on a multitude of different projects doing, games, 3D stuff, SaaS things, and you know, so I have a deep background there. Josh, you want to?
Sure, fantastic. And Dustin's going to be taking us through the product demo in just a few minutes. So when we talk about the digital business, this is the idea of companies moving from traditional, I would say, on-premise, brick-and-mortar companies into online. So online can mean the web, or online could mean, you know, mobile, but they're companies are making a shift from, you know, to be more engaged with their customers, where they are, when they work, you know, to social media and all of those sort of different engagement models to get closer to customers. So they're building these new digital experiences. Now, what this has led to is that customers' expectations about what they can get from companies are changing. People, you know, so they're constantly expecting better and better experiences because there's a lot of competition. Other companies are also making the transformation and creating new digital experiences, and so there's, you know, companies want to get there faster. They want to be able to satisfy their customers better and more quickly. Otherwise, you know, someone else did. So this has led to companies, from an IT perspective, instead of delivering applications once a year or once a quarter, to try to be delivering continuously, so almost instantaneously. And so the consequence of delivering in this way is that if you're delivering a new web application or a new mobile application, particular to consumers, you don't know beforehand what the adoption is going to be. So you have to plan to deliver this at more of web scale. The idea that if I deliver a mobile application or if I launch a new website and it suddenly becomes very popular or very critical, that people may start using it, and they might use it a lot. And so I need to make sure that in addition to being able to deliver continuously, I need to be able to deliver in such a way that the systems themselves are highly scalable and available, and able to work in this new interconnected world of social media, where one celebrity could put a link to your website on Twitter, and now suddenly there's hundreds of thousands of millions of visitors to the site. So the way that people are addressing the scale challenge is through the use of cloud technology, even if that's, you know, on-premise or hybrid cloud, you know, different mobile applications. In the future, I think we'll see more and more innovation in the industrial sector, so smart components that know how to talk to each other and adjust themselves in real time, driverless cars, all of those things. So the ability now for technology to deliver is amazing, and companies more and more, to stay competitive, are taking advantage of this technology to deliver new important solutions. So in order to support the demand of these new digital businesses, information technology is undergoing a number of significant changes. The most significant change that we've seen is that companies are automating their IT infrastructure. So they are, instead of taking physical servers, deploying them into a physical data center, manually provisioning an operating system, and then, applications on top of it. They are trying to automate as much of that process as possible. And they're doing it for 3 reasons. The first reason that they're automating their IT infrastructure is to reduce costs. So by using tools or by using cloud technology, they're able to make smarter use of data centers, to be more strategic with their data center usage, can really optimize it by using commodity hardware, and they're also able to do more with less. So fewer people can using tools that automate deployments or automate provisioning, then you need fewer people to do the same amount of work. So the second reason why people are automating their IT infrastructure is to reduce the time to market. So as we talked about, there's a lot of competition in the digital business. And for large companies, some of their businesses are being challenged by smaller startups who are able to go and produce an app very quickly, who are able to be much more responsive to the needs of their customers. And so what we're seeing more and more is that traditional enterprises are looking to get to market faster. So Facebook, I believe, says that they can go from checking in source code to production deployment in just 16 minutes. So from the time the developer commits a feature to production is only 16 minutes. And enterprises who today are delivering software once a quarter or once a year are really looking to do better, to improve the velocity of their deployment. The other benefit of being able to deploy more quickly is that you can get more real-time feedback from your customers. So if you're deploying a website or a mobile application, you can track the usage. You can see if there's some features that are more popular, then you can continue to invest in those features. If there are features that are less popular, you can either scrap them or refactor them. But all of this encourages people and companies to get to market quickly, to measure the results, and then to change. And that whole cycle delivers significant value for both customers and for companies. The third reason why people are automating their IT infrastructure is to reduce their risk. So if we think about a security vulnerability, if you can automate the patching of systems or automating the deployment of a fix to an application security vulnerability, then that significantly decreases the window of exposure. It also allows, if you're doing more and more automation, to get application developers to be much more engaged in information security, to share the responsibility along with the information security and operations team for that the applications themselves are safe. They're not using any known, so they're not using libraries that have any known vulnerabilities, that they're doing automated security testing to make sure that the applications themselves are safe sooner in the process before they get to production and where they might be vulnerable to a hack or attack. So those are the 3 reasons why companies are automating their IT infrastructure. Now, DevOps is really the convergence of development and operations working together to be able to deploy software in the manner that I just described. The idea is that you can automate your IT infrastructure securely by having developers and operations and then security work together as a team to deploy software in this way. So if we look at this chart, a developer can go and commit a change to an application in source control. That is then built using an automated, the build is automated and kicked off. If the build succeeds, then we go and trigger a set of automated unit tests. If those tests pass, then there can be an intermediate code review, but that code review could be done by people, or it could be done with application scanning tools that review the code for quality, but also vulnerabilities. And then finally, upon approval, the artifact itself is then going to be deployed into this infrastructure. And again, that deployment can be done, is not going to be done by a person, but as part of a powerful machine or job. And now the containers, which we talked about, or Andre talked about a little bit in the introduction, really are a whole new level of this model, because the container itself is what gets checked in, is what gets built, is what gets tested, and is exactly what gets deployed. So, and that allows people to go very, very fast, because each container has an isolated set of functionality, and then these containers are orchestrated together into a cohesive system up into deployment. So companies are moving from static, monolithic, on-premise applications to more dynamic, hybrid cloud, containerized applications. And the idea is that you want to have consistent security throughout this entire life cycle, through the build process, as well up into the runtime. By externalizing that security and making consistent, you can be assured that by the time the application gets into production, everything is going to be okay. It also eliminates this idea that of having different security controls in non-production versus production, which is often a cause to problems. I mean, it ultimately lets people deploy quickly, but with confidence that what they're deploying is going to be secure. So it's interesting that in this new world where people are deploying up to the cloud and containers and applications extremely rapidly, that still, Gartner predicts that 80% of the breaches are going to be due to misconfiguration, poorly managed passwords, and insider theft. So when you build these automated systems to do this automated deployment, if it's not done properly, you can wind up with a number of passwords for things like the automation systems or passwords that are used by developers to get access to go deploy up to the cloud. And those are going to be very powerful credentials. And if those credentials aren't handled properly, then developers can gain access to production data, or if developers leave, you're not really sure who has access to which information. And so as much as people want to move very quickly to go deploy in this way to be competitive, it's quite easy to make mistakes, particularly when it comes to the handling of credentials. The idea here is that as you automate more and more, there's going to be a lot more privileged applications and privileged identities in the system in order for it to go quickly. So there was so if we think about this new world where there's a lot of automated deployment and a lot of very powerful systems, you wind up with these credentials, it can be a real challenge. So there was an article a few months ago in CIO magazine that said, is DevOps good or bad for security? And what the article highlighted was the fact that since a lot of this automated infrastructure is being built by developers to go very quickly, was that the credentials often wound up mismanaged or mishandled. In fact, it was quite a common scenario that the credentials themselves were placed in source control. So the idea is, if you're always building infrastructure and building applications and deploying it seamlessly, it goes to reason that you're going to have a lot of this configuration and infrastructure coded and into source control. So unfortunately, people then put database passwords, Amazon API keys, X509 certificates, SSH keys, etc., into their source code repositories. Now, source code repositories are good for storing source code, but they're not always locked down and treated with the same amount of security scrutiny as they should be. So there's been a number of cases where applications have been exploited simply by getting into the source control, finding extra credentials. It's quite a common attack where, and it's mentioned in the article, where hackers will look for Amazon API keys and then go spin up infrastructure and then go mint Bitcoins, create digital currency in someone else's account. So this is a consequence of going quickly, and developers can't be left on their own to simply manage the credentials themselves. They need to be brought into a more appropriate governance model. So why is access management harder today? So if we think about this new world, which is the digital business era policies, and compare it to where we were before, which is more of a legacy IT. So certainly the complexity is increasing. If we think about deploying, instead of monolithic applications, to more of a microservices architecture with Docker services working together, some of those components, perhaps third-party or remote APIs. There's just a lot more moving parts and interconnected systems that need to be accounted for. Today, much of this infrastructure is manually provisioned by people, but in the new world, or in the DevOps world, much more of the infrastructure is provisioned automatically by code. Today, infrastructure can be provisioned within days or weeks. Ultimately, projects roll out over quarters or years. But going forward, companies and their customers expect them to be able to deploy and respond in seconds or minutes. The applications themselves are primarily inside of your data center, and so enjoy all of the layered protections of the data center, including the network and operating system, the physical data center. But going forward, applications are going to be deployed a combination of on-premise and up in the cloud with mobile applications. And so since much of the communication and interaction is going to be over the internet and in remote cloud providers that are outside of the control of enterprises, there's a whole new set of risks involved. Applications lifespan, if it takes a year to get to production, are likely going to be in production for a long time, whereas in this new world model where customers expect changes constantly, some of these services are going to come up and they're going to run for a very short period of time. If we think about containers, many containers only run for 3 minutes. They're spun up, they do a specific task, they transmit that data someplace else, and then they stop. So you're moving from a very static set of compute resources to a much more dynamic, vibrant environment. In today, we think about legacy IT, we're certainly concerned about insiders and malicious insiders, but those are mostly about people, administrators doing something that they're not supposed to do. But if we think about this more dynamic new world, in addition to people, you have libraries being downloaded from all over the internet, interacting in unpredictable ways that could be, and this represents a whole new threat surface for the digital business era. So let's talk about Conjur. So Conjur is a product in a company focused on digital business security. We want to maintain a secure environment with so many connections without slowing delivery speed. And the idea is that we can make it safe for you to move to this new world of digital business safely and securely, and innovate in such a way that you can meet the demands of your customers, that you can automate your IT infrastructure, that you can adopt the DevOps methodology, but do it in such a way that you're still safe and secure and compliant. So what is Conjur? So here's a picture of the Conjur dashboard. Dustin will give you a demo in a minute or so. He's going to take you through the product, but we're really about identity and access management for people, machines, and code. So this transformation from the current model, the current IT, current IT model to this new world is going to take some time. And so during that transition, you're going to have multiple clouds that need to work together. You're going to have a combination of people and machines working together, and you're going to need to provide a comprehensive and overarching view of the security of the entire build and production pipeline. And Conjur is a product in the company focused on solving those challenges. So what Conjur is from a product perspective, and Dustin's going to show you some part of this in the demo, is that we're really about privileged access management, but a much more modern approach. Gartner even calls it PAM for DevOps. And this covers the new set of privileged identities, more than just people, but assigning machines identities to machines and jobs, and managing secrets, SSH keys, etc. Dynamic traffic authorization. So if we're building out microservices architectures and all of the components are going to spin up and communicate with each other, you need the ability to identify all of those services and to authorize and broker the traffic among them. And then finally, compliance and reporting, which is a comprehensive policy model and the ability to derive real-time and historical reports about all the access across the build and production life cycles. This is all tied together by Conjur's core, about policy identity definition that Dustin's going to show you. And our strategy is to be able to work with your digital business infrastructure. So work with your team, your processes, and your technology. So I'm going to turn it over to Dustin to give a demo, and then I'll continue back with to close out the presentation.
Hi, everyone. It's Dustin Byrne. I'm going to walk you through the demo here. So what we're going to do is just briefly look at the Conjur UI and talk a little bit about some of the high-level concepts that we see here. So first, we'll take a look at these numbers that are shown here. This top row here is really around identity management. So these first two boxes that you see here are around users and groups. So this is your typical users and groups that can be synchronized from Active Directory or an existing LDAP server. So you can log into Conjure, see what's available to you if you're eligible to read, or if you have permission to read any secret values, those will be available to you. However, on the right hand here, we have identity for hosts. So these are machines or VMs or containers, anything that's essentially running code that's going to need some sort of privileged access to a set of, let's say, secrets, or we want to give user access to a group of these machines. And when I say a group of these machines, in Conjure's case, we call them layers. So you can imagine we have different applications which are split up into different layers, so we can give them different privileges. Some of these things could be saying, like, the user group developers has SSH access to front-end web server hosts, things like that. And as Josh mentioned, in this new age of technology, things are really moving away from not just users' permission, but also now into machines' permission, access to privileged resources for machines, particularly when you're working with a lot of automated workflows, right? So you can imagine your Jenkins job needs access to some set of API keys, loading that application up into your cloud providers, another set of API keys, and then there's another set of privileged credentials within the application itself. So within this three, from Jenkins to the cloud to your application, are really three separate identities that may need different credentials at runtime. So following that, we have web services. This is really around traffic authorization. So if we have different microservices or web services, being able to say web service A can communicate with web service B, but we want to block all other traffic unless it's authorized through Conjure. Secret values, so again, this is anything you wouldn't want to wind up on the public internet. So API keys, database passwords, private keys, certificates, things of that nature. And then this final box here, well, it says we have 0. The concept here is that any one record within Conjure can be tagged or annotated. So if we had a bunch of machines which were SOX compliant, then we could tag them as such, and then later on filter based on which hosts are SOX compliant, and then see information regarding those. We also have charts that just show general activity, so users SSHing to machines which are in the Conjure inventory, people reading secrets, and we also see our most active secrets here. Now this is a demo environment, so there's not a whole lot of activity going on here. But if I continue down, we have a bunch of audit data. So every single record within Conjure, and then any action or event pertaining to a record or multiple records, will generate some audit event within Conjure. So this could be something from a user establishing an SSH connection, to possibly a warning, somebody SSH'd to a machine and then tried to do something they were not privileged to do, so we'd see a warning for that, as well as users or hosts fetching secret values. And then at any one point in time, we can actually drill into one of these records and then get more information regarding that record. So audit data, privileges that record may have, if it's a user or a host, things like that. And then also with users, we're able to, down at the bottom here, if you see, we have this tab for public keys. So with a single user, you can associate a number of public keys with that user. So as they go and SSH to a host that's known to Conjure, we can authorize them and see if they actually have the privilege to be on that machine. So you can imagine Conjure is sort of your single pane of glass into this new age of modern infrastructure. So if I jump over to hosts here, you'll notice we have a number of hosts, some of which are, analytics 1, 2, and 3. So this is really around how Conjure works, especially well around automated infrastructure. So the idea here is if you have some sort of auto-scaling group or ephemeral hosts that are coming up and down for whatever reason, the creation of their identities can be totally automated, right? So in this case, if we have, let's say, servers that are running some web service, in this case, an analytics service, as they're coming up, we need them to be able to fetch the credentials that they need to be able to run. Maybe this could be a database password or some cloud API keys, something. So the way we do that is we split everything up into layers, essentially just groups of hosts. So we can put down on this analytics layer. This analytics layer needs access to these database credentials, and then we use what's called a host factory token to go ahead and register hosts at launch time to go ahead and they exchange this token with Conjure for a machine identity back. And then using that machine identity, they can go ahead and retrieve their values at runtime to go ahead and run their whatever process they need to run. So as I mentioned before, users are typically synchronized from LDAP. So we have a bunch of LDAP users here, as well as groups. So we see some groups in here that were created with an LDAP. We also have a number of groups that were created just within Conjure. So Conjure also functions as a virtual directory, so we can synchronize LDAP as well as serve as a directory to plug in with things like Jenkins or anything else that takes in LDAP protocol. So then you can leverage this RBAC model in other applications as well. And the way all of this is sort of tied together is using policies. So a policy is just a group of records that define a single application or a workflow, and then the permissions around those records. So if we quickly take a look at this front-end policy, so this is a policy for a front-end web application that's running in the production environment. This could be dev, stage, whatever, some other environment, and then these records would all be totally unique, and the permissions would be, again, unique. So for this front-end web application, we just need to define what sorts of credentials we need to be able to run this process. So we have some database credentials, an SSL certificate, and an SSL private key. So these are the things when this front-end host or container or VM comes up, we'll need to fetch these values. And all these permissions are defined at the layer level. So as the host is created, it's automatically added as a member of this front-end layer, and then it gets those privileges automatically. And then we have a group just for convenience, a user group here, so secrets managers. So if we add Bob to the secrets managers group, he can go in and edit the secret values. However, if we deployed this in dev, we could say things like we want developers to be able to update the secrets because they're not all that sensitive in the development environment. However, in production, we don't want anybody to actually know those values, so nobody's a member. Instead, we want to automatically rotate those secret values. So scrolling down here, what we call that is entitlements, right? So being able to say things like developers have SSH user access to hosts in the front-end layer, things like that, and then defining different entitlements per environment. I think that's good for a demo. Do you want? Yep. So I'm going to hand it back over to Josh, and we'll continue with the slides.
Thanks, Dustin. That was I really appreciate you giving people an overview of the product. So, so really, what makes Conjur's unique? It handles the speed, complexity, and scale of digital business. So Conjur's built for scale, thousands of devices with varying life cycles and durations. Many of them, jobs or containers that need an identity so that they can access protected resources like other APIs or secrets in a secure and auditable fashion. So Conjur as a company is a modern company. We've been around for about three or 4 years, and so it's a modern architecture. It's distributed. It's meant to work in this new world of multi-cloud and hybrid cloud with Docker containers. It's meant for fast reads and nonstop response, and all of this aligns with the way in which companies are building their applications. And so each of the tools is really, though it's a centralized model and a consistent model, each type of person that needs to interact with the system gets the tool that they want. So developers get APIs, operators get a command line interface, and for security and compliance, they get simple UIs and dashboards. So this is a type of, Conjur provides a way in which information security teams can get engaged with modern deployment and deliver to own and operate and deliver a solution that is going to be well accepted, if not enjoyed, by application development teams. It's the type of tool that works with the other components in their ecosystem, and it's easy for them to adopt, and they almost, they get all of the benefits of having the centralized policy and RBAC model effectively for free. So Conjur, no customers in Brazil yet, but certainly we do have a number of I think companies that you'll recognize. Conjur customer base has been primarily in Silicon Valley, in California, so companies like Netflix and Cisco and Box, but we're now seeing more and more traditional enterprises like the Royal Bank of Scotland, the Discovery Channel, start to look for Conjur to change the way in which they're delivering software, and therefore recognize the need recognize the need for a new set of tools to support that transformation. So if we think about the new privileged access management landscape, on one hand, you have your legacy on-prem solutions. Then you've got a set of single cloud or single technology stack solutions, such as what would be provided for you inside of Amazon or Azure or Docker native, and then the ability to work across clouds. That's the horizontal axis. Then on the vertical axis, what we see is a set, in the lower left-hand, the bottom, people-oriented, and then as they move more up towards code, machine, and DevOps-oriented. So Conjur is really the only solution which is focused on, both on-prem and multi-cloud in a sort of hybrid cloud model, and for code, machines, and DevOps, moving away from strictly insider threat by people. So here's a couple of takeaways to securing your digital business. Take a step back and think about who needs access to what and which systems need access to what. So modeling your policy in Conjur can be done simply. It gives everyone an idea about what the rules are and makes people feel invested in the process. 2, everything needs an identity. So yes, we have a system today where people have usernames, an identity in something like Active Directory, but what about all the infrastructure that you're going to spin up and make it in dynamic infrastructure? What about all the tools and jobs that are part of the build process? All of those need an identity, and as Dustin explained, can be given a role and therefore a set of privileges appropriate and limited to their function. If you don't identify all the things, then you wind up with the proliferation of very powerful credentials, and that can lead to challenges. So by having a centralized access policy model, it's a consistent model. So thinking about an overarching view of who has access to what in all of the systems, but also you can delegate much of the administration to various business units and various teams. So just because you have a comprehensive model, it doesn't mean that the central security team becomes the bottleneck and has to operate all of it. So Conjure and part of RBAC has a delegated administration model that empowers teams to go do more and participate in this process. But RBAC will give you a consistent model and will give you visibility across the scope of the deployment to satisfy the needs of your auditors and your regulations. So think about software delivery in a heterogeneous environment. It's very dynamic. Costs are coming down for cloud. The cloud vendor today may not be the cloud vendor for tomorrow. So if you're locked into any particular model, switching could be very expensive. So planning up front for a heterogeneous deployment will leave you better positioned to deliver on the digital business. And then ultimately, auditability, you need to be able to get audit of all the changes to all of your policies, to all of your applications in real time in order to ensure and convince your auditors and your own internal controls that you're doing this in such a way that isn't going to lead to compromise. Nothing will destroy a digital business initiative like a security breach or some other problem. So I think that's all the time that we have, Andre. It's all the slides that I have. So I'd just like to say thank you very much, and I'll turn it back to you.
Okay, Josh, thank you for your presentation. I will turn to Portuguese to thank you all the people, but anyway, thank you for all staff, Conjure staff, to be with us in this seminar. Bom, eu gostaria de agradecer a presença de todos. A ideia é apresentar exatamente novos modelos de segurança, que na verdade é a única forma de garantir segurança hoje em dia, nesse mundo de transformação digital, containers, cloud, e alguns elementos bem importantes é o nível de segurança, são questões de performance, de latência, de agregação, de função numa única solução. Então, espero que tenha sido produtivo para todos. Agradeço a todos, ficamos ao inteiro dispor de esclarecer dúvidas posteriormente. Conjure team, thank you very much for everybody.
Thanks so much, Andre. Thanks, everyone.
Thank you.
Bye.
Bye-bye.